That Lori doesn't want to talk to me because I'm pregnant. I was like, where did you hear that from? She was like, someone told us. I was like,
Alright, let's take a look at number 5 here. On number 5, we are given 2 pieces of information. Okay, I'm told that x, y, and uv are congruent. So remember, one thing we did was mark that on the diagram. So I'm told this is congruent to this. And then I'm also told that yz and tu are congruent. So yz is this piece, and tu is this piece. Then I want to prove that xz and tv are congruent. So first line is my given information, right? So we always know that first line is given. Well, now they say, well, if these segments are congruent, their lengths are equal. What property or postulate or definition lets me say that?
Symmetric.
Not symmetric. Definition of congruence. If I know that 2 things are congruent, then I can say those same 2 lengths are equal by the definition of congruence. Well, now they've got a couple of equations on here. Now they say xy plus yz equals xz. So xy plus yz equals xz, and then also tu plus uv equals tv. Why am I allowed to say that? Yeah, right? If I add 2 pieces together and say that equals the whole thing, that's the segment addition postulate. Well, now they change these equations a little bit. Okay, so if I look at this first equation, what changed from this equation to this equation? Yeah, so the only thing that changed was this xy became uv, right? And I'm allowed to do that because I know they're equal. So I can substitute one in place of the other. Same thing over here. Tu became yz, and I'm allowed to do that because they're equal. So that is the substitution property. Well, now, how can they claim that xz and tv are equal? It's going to be transitive, right? Because what we're saying is I've got uv and yz here, and then I also have uv and yz here. So I'm saying that tv and xz are equal to the same thing. If they're equal to the same thing, guys, I'm up here. If I'm saying that those 2 things are equal to the same thing, then they're equal to each other by the transitive property. And now, finally, if I know 2 lengths are equal, I can say those same segments are congruent by definition of congruence. Alright, we okay with that one? Alright, let's take a look at number 6 together then. See how you did on this one. So again, we're given 2 pieces of information. So we can mark those on the diagram first. So I'm told that YW and YZ are congruent. So YW and YZ, those are congruent. And then I'm also told that XY and VY are congruent. tick marks on there. So, first line is just that given information. The next line, we're saying if those segments are congruent, then those lengths are equal. What property or postulate or definition is that? Right? Definition of congruence. Okay, well now they claim that xy plus yz equals xz. How can I claim that? Segment addition postulate. Yeah, right, that's two pieces added together, make the whole. Then they say Vy plus Wy, or I'm sorry, Vy plus Yw equals Vw. Well, I think. Oh yeah. That would be because all that we're doing is substituting. Are we? Is that right? Yeah. 5. Oh yeah, 5 is substitution. I was looking at number 5. Yeah. So here, I think we are also actually substituting, right? Because we're saying xy and vy are equal, so I can substitute that. And then here, yz and wy are equal, so I'm substituting that in. Okay, so since I know those two things are equal, I can substitute one in place of the other. So here, we can say substitution. Now for 5, now they're saying Vy plus Yw equals Vw. And so this one, we're looking at the diagram again, saying this piece plus this piece equals the whole thing. So I think this one would be segment addition again. So if we look at this statement, it says Vy plus Yw equals Vw. Yeah, so we're saying this piece plus this piece equals the whole thing. That's segment addition. So now they claim that xz and Vw are equal. How can I do that? I think I heard it. Transitive. Yeah, right? If we look at lines 4 and 5, we've got Vy plus Yw. So I'm saying xz and Vw are both equal to that. If they're equal to the same thing, they have to be equal to each other by the transitive property. And now, finally, if I know two lengths are equal, I can say the segments are congruent by definition of congruence, right? Any questions on these? Alright, so on the back, there are just a couple more proofs, okay, we're going to look at today. Now these ones have a couple of missing statements and a couple of missing reasons, okay, a couple of missing things on both sides of the proof. Alright, so let's go through this first one together, and then see if we can try one or two of them.
Alright, so the first one should be given. Right?
First one should be given. Right. E is the midpoint of AC. I'm given that. So now, they tell us the reason in the second one is going to be definition of a midpoint. So if I know E is the midpoint of AC, what can I conclude by the definition of a midpoint? So yeah, we're going to have an equation here saying that two pieces are equal. Exactly. AE and EC. Yeah, so if I know that E is the midpoint of AC, what I can say is those two pieces, the two halves of that segment, are equal to each other. Okay. That's just the definition of a midpoint. It cuts the segment exactly in half, so the two halves are equal. So we can say AE equals EC. Well, now in line 3, they say that we're going to use the other piece of given information now. So the other piece of given information is just DE equals EC, right? Well, now somehow they claim that AE and DE are equal. How can I do that? So in line 4, they claim that AE and DE are equal. Is that a definition of midpoint? No, it's not going to be definition of midpoint. So we're going to have to look back at both lines 2 and 3 and see how we can claim that AE and DE are now equal to each other. No, definition of congruence is just when we're going back and forth between equality and congruence with the same segments. We could use substitution here, or we can use transitive. Okay, both of those would work. All right, so in lines 2 and 3, what we can do is say, well, I can substitute AE in place of EC, right? Since I know they're equal, so we would get DE equals EC. So that would be substitution. Or if we're thinking about transitive, I know that both AE and DE are equal to the same thing. They're both equal to EC, therefore they're equal to each other. So either substitution or transitive would be correct answers here. Well, now, if we know AE and DE have equal lengths, what can I claim by the definition of congruence? They give us the reason. Exactly, yeah. Right? If I know the lengths are equal, we're just going to say the segments are congruent. Right. So now, that's really close to what we wanted to prove, but to technically get it correct, they flip it across the congruent sign. So that's the symmetric cross. Yeah, I slipped up and said it there, didn't I?
So let's go through 8 to get to 2.
You guys feel like we should go through 8 together?
No, I don't even care about what's going on. This is the part of it that has Friday right now.
Sure. Let's go ahead and do number 8 together as well then, and then I'll have you guys try number 9. Alright, so on number 8, the first line we know is the given information, right? So RS equals 1/2 of RT. Well, now in the next line, somehow they claim that 2 times RS is equal to RT. How can I go from this line to this line? Yeah, right? We're just going to multiply both sides by 2. So times 2 times 2. 1/2 times 2 is just 1, right? So that's how we end up with this line here. So that's just the multiplication problem. So now they tell us that the reason in the next line is segment addition. So looking at this figure that I have, what equation could I write down using the segment addition postulate? JC? Yeah. RS plus ST equals RT, right? Add the two parts together, and that would equal the whole. Well, now we've got a new equation. Right? Now they say 2RS equals RS plus ST. How can we do that?
Wait. How do you get 2 RS together?
That's what I'm asking you.
Is it multiplication?
No. So for this one, we have to look at lines 2 and 3 to figure out how we got 4. So what can we notice in both lines 2 and 3? What's happening here? So yeah, right. In both lines 2 and 3, we've got 2RS and RS plus ST equal to the same thing. They're both equal to RT. So then in line 4, we claim those two things are equal to each other. That would be a transitive property. Okay, whenever we see two different things equal to the same thing, and then we claim that those things are equal to each other, that's the transitive property. Well, now, how can I go from 2RS equals RS plus ST to just RS equals ST? Not division. It's going to be subtraction. Right? If I subtract RS from both sides, 2RS minus 1RS would just be 1RS. And then these RS's would cancel out. So we would get RS equals ST. So that's going to be subtraction.
Why would they cancel out? Because it's 2 of them? No, I'm still confused.
So what if I give you an equation like this? 2x equals x plus y. Okay? And I subtract x from both sides of the equation. So 2x minus x would just be 1x, right? And then x minus x would just be 0. It'd be nothing. So that's why we say those would cancel out, because it would just equal 0.
But there's not a matrix on that
On which one?
one. On the RS.
Yeah, there is. Yeah, we're subtracting it from both sides. Yeah. Alright. So now, the final line, if I know RS equals ST, what can I claim by the definition of midpoint? As the midpoint, right? The final line should be what we want to prove. So, the final line should just be this. S is the midpoint. Of RT. Feeling all right, Dan? Well, so when I do this subtraction, just like this equation here, if I'm thinking about 2RS minus RS, I'm going to have 1 RS left over. So if I've got 2x and I take away 1x, I'm just going to have 1x left. So that's what's happening here, and I'm subtracting one of them away, and I'm just left with one of them then. Any other questions?
What's up with number 10?
Number 10?
Yeah, very
Oh yeah, we're not going to worry about those. We're going to stop at 9. I'm sure, yes.
So we're not doing
9's the last one we're going to do on this paper. All right, so you guys go ahead and try number 9. Okay, go ahead and take a couple of minutes and try.
Yeah, I was so mad.
So you can find my post on Instagram because I had the right website for it.
I told my parents forever, and then I was like, oh, it's raining. How nice.
All right, let's take a look at this one together here. So, hopefully we all got the first one. Okay, the first one is given.
That was the hardest one.
That's the hardest one. So then they actually give us everything for line 2, right? They tell us, well, if M is the midpoint of Ln, then Lm and Mn would be equal by the definition of a midpoint. Line 3, then, they tell us is the other piece of given information. So that's just going to be, right, N is the midpoint of MO. Well, now, they claim from this information that Mn and NO are equal. So they're telling us that N is the midpoint of MO, therefore Mn and NO are equal. Why am I allowed to say that?
Because Lm equals NO. Oh, wait a minute.
Not yet. We're on line 4.
No, definition of midpoint because of Mn equals NO.
Right. It's the same idea as what we just did in lines 1 and 2, right? If N's the midpoint, then I can say the midpoint cuts that segment into 2 equal pieces. So these would be equal to each other. Well, now at line 5, they say we're going to use the transitive property. So how can I use the transitive property here?
Because Lm equals Mn. And you
No,
got,
N-O.
and you got Mn equals NO. Therefore, Lm equals NO.
Exactly. Right? I've got these 2 things, Lm and NO, both equal to the same thing. Right? They're both equal to Mn. Therefore, they're equal to each other.
Exclusively by Mr.
Yeah, I invented that.
That's impressive.
I know, right?
No, she just helped me understand.
Good. So now the last line says we're going to use definition of congruence. So if I know these lengths are equal,
LMY equals squiggly, no.
The squiggles is also.
that's it. Right? If I know the lengths are equal, the segments are congruent. Right? Any questions?
Guys,
On
do
these.
you mind if I jump in for a second?
Sure.
I think you guys
Yeah.
are struggling just a little bit with the transitive property, and I know from last year kids had a hard time with that. So one way you can do it when you see that is if you're trying to figure out which one to put here, I always cover up what's the same. And then I'm like, okay, so that means those 2. Another way is to highlight each one, and if you end up with 3 colors, that probably is transitive.
Yeah.
Just a little tidbit from last year.
Yeah.
So on a test, if we put maybe work that wrong.
No. Yeah, most of the time. But like in this example, like they tell us it's transitive.
I didn't know if there was like a word wrong.
What's that?
I didn't know if we could right.
No. Most of the time,